It is one of the most widely used metals in the world. Every day, more than 100,000 tons of copper are produced. China alone consumes more than 14 million tons a year. To obtain just 1 ton of copper, nearly 200 tons of rock must be extracted. But have you ever wondered how copper is made? We visited one of the largest mines in the world to discover how one of the most valuable metals on the planet is obtained. Modern civilization could not function without it. This metal is present in almost every aspect of our daily lives. It is part of engines, heating systems, and the electrical cables that power our cities. Copper is one of the best conductors of heat and electricity, with exceptional resistance to corrosion. It is very flexible and malleable and can be recycled indefinitely. But where does copper come from? Copper is found in the Earth's crust, in the most superficial layer of the planet, mainly in sedimentary rocks, and its extraction is a complex process that includes several stages. The first step is to identify areas with potential copper ore deposits. This requires geological studies, sample analysis, and prospecting techniques to find places where copper is present in economically viable concentrations. The Chuquicamata mine stretches across the heart of the Atacama Desert in northern Chile, surrounded by an arid and extreme landscape. This gigantic excavation is one of the largest open-pit copper mines on the planet. Each year, more than 300,000 tons of copper are extracted from millions of tons of rock. But before reaching the valuable ore, enormous layers of waste material must be removed. In some areas, the deposit reaches depths of 100 meters, which requires colossal machinery and tons of explosives to extract the copper-bearing rock. A huge drilling machine makes around 130 holes known as blast holes, each at least 16 meters deep, the height of a 5-story building. Each hole is filled with a powerful mixture of ammonium nitrate and fuel, along with a quantity of a high explosive called AMPO, and then backfilled with waste material from a safe distance. An operator activates the charges, detonating them in series. Each blast is so powerful that it could bring down an entire skyscraper. The time between one explosion and the next is about 2 milliseconds. This blasting pattern is designed to fracture as much copper-bearing rock as possible. Thanks to technology and carefully designed blasting patterns, the explosive energy fractures the rock underground, minimizing the spread of material and dust after the blast. Once it is completely safe to enter the mine, the ore loading begins. Giant shovels lift the material with their large buckets and deposit it into enormous mining trucks. 1 ton of ore is needed to obtain 6 kilos of copper. Therefore, to obtain 1 ton of copper, nearly 200 tons of ore are extracted. Excavators lift between 55 and 88 tons at a time. That rock contains less than 0.5% copper. The trucks are nearly 7 meters tall and can carry up to 400 tons, meaning they could transport up to 300 cars. Because of the enormous size of an open-pit mine, operations are managed from a control center located in a tower similar to those in airports, from where the entire site can be monitored. But how is a piece of dark ore turned into one of the most used metals in the world? Releasing copper from ore requires different techniques depending on whether the ore is oxide or sulfide. To process oxide ore, the rocks are stacked in special leaching areas. The material is deposited on the periphery of the mine to begin the leaching process, where it is irrigated with a diluted sulfuric acid solution. Over weeks, this acid slowly seeps through the rock, dissolving the copper. The solution, now loaded with copper ions, is collected in ponds and directed to the processing plant through a special channel. The copper solution is combined with an organic reagent and floats to the surface. Then an acidic solution is added to increase the copper concentration and make it electrically conductive. The solution is transferred to a series of tanks with thin copper plates called cathodes. An electric current is applied, and copper ions begin to deposit onto the plates. In just 10 days, each plate reaches a thickness of 2.5 centimeters and a weight of about 125 kilos. The purity reaches 99.99%, which is essential if the copper is used to make electrical products. Extracting copper from sulfide ore is a more complex process. It begins in a gigantic drum known as a mill, where steel balls grind the wet rocks into fragments. Upon leaving the mill, the material passes over a perforated screen that separates smaller pieces, which continue to secondary mills, while larger stones return for another round of grinding. Once pulverized, chemicals are added to coat the copper particles, and a foaming agent is mixed in. The mixture enters flotation tanks, where air bubbles carry the particles to the surface. This copper-rich foam is collected and filtered to obtain a concentrate with a purity between 25% and 30%. The next step takes place in the smelting plant. The concentrate travels by train to huge yards, where it is layered with silica sand known as flux. This sand helps remove impurities during smelting at extreme temperatures. The mixture turns into a molten liquid, with slag made of iron and other minerals floating while copper sinks. At this point, it reaches 60% purity. It then passes to a second furnace, raising the copper content to 98%. The molten residue is poured into a heap, a stream of glowing slag flowing like molten lava. Once cooled, it solidifies and becomes part of the landscape. Meanwhile, a crane transports the molten copper to another furnace for final purification. Purity increases to 99.4%, and the molten copper is poured into molds, forming large rectangular slabs called anodes. These slabs are cooled with water sprays and solidify. A hydraulic cylinder ejects them from the mold, and an automated system moves them to a rinsing station to remove mold release agent residue. They are then sent to a refinery hundreds of kilometers away. At the refinery, maximum purity is achieved. The anodes are immersed in electrolyte tanks opposite thin metal sheets called cathodes. When an electric current is applied, pure copper transfers from the anodes to the cathodes, while impurities fall to the bottom of the tank. The result is 99.99% pure copper, suitable for making the most demanding electrical cables. This molten copper is introduced into a vertical furnace, melts, and flows to the bottom. From there, it is channeled into a mold-forming rectangular blocks about 6 meters long. The molten copper passes through an opening in the mold and is cooled with water, forming a continuous rectangular bar. Rollers significantly reduce its diameter, transforming it into a copper rod about 7 millimeters thick. The rod exits the system, and the machine coils it into a spiral. The coils fall neatly onto a steel reel, which is then compressed to take up less space during transport. This reel of pure copper will be turned into conductive wire ready to carry electricity around the world. Give the video a like if you enjoyed it and share it with someone who might be interested. Also, subscribe to this channel and activate notifications to keep learning.